Hello, welcome to Andrew Academy. My name is Nguyen, and now I'll be talking to you about the molecule carbon dioxide in chemistry. Carbon dioxide is CO2, and it is a molecule that causes global warming around the world. This molecule blocks the radiation from going away from the atmosphere, which heats up the world slowly. And in this picture is how the process takes place. Now we're going to talk about the molecular geometry about this molecule. First of all, molecular geometry is the three-dimensional arrangement of atoms in a molecule. According to the VSEPR theory, or valence shell electron pair repulsion theory, it states that all electron pairs repel each other, so they want to get away as far from each other as possible. According to the Lewis structure of carbon dioxide, it has two bonding electron regions and no lone pair electron region, as shown here. Since it only has two electron regions total, which is oxygen 1 and oxygen 2, bond to the central atom, which is carbon, it forms a 180 degrees bond angle. Now, I'm going to discuss about the polarity of each bond in the carbon dioxide molecule. But before I do that, in here right now is how it looks like in 3D form, the Lewis structure of carbon dioxide. And that white line in the middle of the left picture is not supposed to be there, which is just part of a background that has been cut off. So to the polarity, since it has a symmetrical linear shape, the polarity is nonpolar, meaning that one atom has greater attraction of electrons than the other atoms. Why we know that it is nonpolar? Because according to electronegativity, or the ability of an atom in a particular molecule to attract electrons to itself, the 2 oxygen is more electronegative than the carbon, as shown here, where oxygen is more to the right, which electronegativity increases as you go up and to the right, and oxygen wants to gain two more valence electrons, so it can have a shell of 8 valence electron. Since it has 6 already, and carbon only has 4, so oxygen would really want to get to there first before the carbon would, because since it has 6 already, the attraction would be greater. So it creates a dipole movement with the 2 carbon-oxygen bond going in opposite directions. For those who don't know what dipole movement is, it is the separation between positive and negative charges. The carbon is partially positive and the oxygen is partially negative. Because again, oxygen has a higher electronegativity than carbon, so carbon will be left alone for a while with no electrons, thus making it partially positive, and oxygen will be filled with more electrons, making it partially negative. So the pull of the oxygen to get away from the carbon as much as possible makes the charges cancel out, which causes no overall dipole moment in carbon dioxide. Now to the electron configuration of carbon dioxide. In carbon, first you gotta find the total number of electrons in carbon, which there are 6 electrons total. Now to write the first principal energy level, you start off with 1s squared or 1s2, in which each orbital can hold 2 electrons. The 1 indicates the principal energy level, the s means the orbital type, and the squared or 2 would mean that there are 2 electrons in that orbital. To the second stage, you start off with the s orbital, 2s squared. Now you have 4 electrons. Then add 1 p orbital, which will bring you up to 6 electrons total. Now you have enough electrons for carbon. As the Pauli exclusion principle states, no 2 electrons can have the same spin in the same orbital. So for each orbital, you draw a line going up and a line going down to indicate that the electrons are not going in the same directions. Here's how it looks like. See how there's up and down lines for each orbital? As again, it means that they are going in opposite spins or directions. So for the valence electrons of carbon, you look for the furthest principal energy level, which is the second level. So there are 4 valence electrons for carbon, as they are 2s squared and 2p squared, or 2s2 and 2p2. Now to the electron configuration of oxygen. First, oxygen has 8 electrons total, so for the first principal energy level, we write 1s squared with the up and down arrows to indicate that the electrons are going in opposite directions. To go to the next principal energy level, there are 8 electrons to complete the shell, so you write the 6 remaining electrons by starting with 2s squared to 2p4. There are 1s orbital and 3p orbital in the second energy level, which explains why there are 4 came from, because the 3p orbitals can hold 6 electrons. Now you write the up and down arrows for each orbital. It looks like this, as it is shown here. For the valence electrons for oxygen, it has 6 valence electrons, because the second energy level is the last energy level for oxygen and is the furthest, so it holds 6 valence electrons currently. That is basically what the structure of carbon dioxide and its elements. So thank you for listening. I hope this helps.